In our last practice problem for number 4, we have gaseous hydrogen iodide made from hydrogen and iodide. So we've got our reaction right here. 1 mole and 1 mole make 2 moles. They're all gases. We have a K value. And here, all of the given values are in atmospheres. That means that we're looking at a Kp, or that when we are setting up our equilibrium constant expression, rather than using the square brackets, thinking about molarities and concentrations, we use the capital letter P because we're looking at pressures. So we have initial values for all three things. The problem is initially looking at those values right here and looking at the K, it's not easy to know what will be made and what will be consumed. We have a little bit of everything. On number 4C, it was a little bit more obvious what would be consumed and made based upon the value of K and the initial values. If you don't know what's going up and what's going down, we solve for Q to figure it out. So Q means plug in our initial values. When we plug in all our initial values, obviously paying attention to coefficients as exponents, we get a value for Q. That's our current ratio of products to reactants. And in this case, that value is bigger than the K value. That means our numerator or our products are larger than they're supposed to be. Our denominator, our reactants, are smaller than they should be. So we need to make more reactants and we need to consume some products. So that's how we know that these are plus X and this one will be subtracted. The other thing that's important here is this is the first example set out of this set, where we had a coefficient. So it is important, not only does the 2 come into play as an exponent, it is also right here. The change row has to agree with the stoichiometry of the reaction. For every one of these that I make, I have to take away 2 hydrogen iodides. So then I can just say, well, I had this much, I added some, and I consumed some, and we plug that into our Kp value. The problem is the math on this is really ugly. You can't just solve for that by simplifying it in any way. We would have to use a quadratic equation that with all these decimals would be very ugly. The other thing you can use is an equation solver, but the nice thing is that the College Board does not require that on the AP exam. You may see it in college, you may see it on some practice problems that we work through, but on an AP quiz test or the AP exam, you will not see that. So I solve for this in my calculator equation solver. You can also use a quadratic solver online. There's lots of ways to do that without needing to do all of your a squared, b squared, all of those things. So save yourself some time and make it simple. I got the value of X, but what's super important here is that that's not the answer. That's why the Rice table is very valuable as well. That number tells me how much more of this I have, how much more of this I have, and how much of this has been consumed. And just as we saw up above, that 2 has come into play. It is 2 times that. So do not forget to pay attention to your coefficients as they become exponents, but also deal with the stoichiometry of the action.